using the late season cornstalk nitrate test. This presentation will cover why the late season stalk nitrate test can be a useful tool for making better decisions for the rate of nitrogen application in corn. We'll also cover the circumstances under which it can be used, how to take samples from the field for testing, and lastly, how to interpret the results of the test. Among all of the nutrients that a corn plant needs, nitrogen is by far needed in the greatest quantity. It is also the most difficult one to manage. Nitrogen exists in several forms within a crop and soil system and can change from one form to another, as shown here within the nitrogen cycle. In the soil, microbes convert nitrogen in organic matter, manure, and in some cases fertilizer, to mineral forms that plants ultimately use. The amount and rate of this conversion is influenced by moisture and temperature. In addition, some forms of nitrogen are susceptible to loss under certain conditions. Given all of this, it is very difficult to predict how much nitrogen is available to a crop over the course of a growing season. On farms where manure is applied frequently in substantial amounts, the nitrogen available from organic materials in the soil to the corn crop can be significant, but can also be variable. Because of the cost of applying too much or too little nitrogen to corn, as well as potential losses to the environment, crop scientists are continually researching ways to better predict, measure, and make better recommendations about nitrogen. Of the various tests that have been developed to manage nitrogen in corn production, the late season cornstalk nitrate test has been shown to be a useful and very reliable end-of-season indicator of crop nitrogen status. Done near the end of the growing season, it can serve as a report card, if you will, of the accuracy of the nitrogen rate that was used that year. This can then be used to make adjustments in the amount of nitrogen applied in the future. How reliable is the test? This graph, based on Pennsylvania research, shows how this test clearly separates fields that were short on nitrogen from fields that had adequate or more than enough nitrogen. There were only 2 cases in which the late season stalk nitrate test level readings were at or above the established optimal level, but corn did not quite reach its full yield potential. That calculates to an accuracy rate of over 98%. But in order to get accurate results, it is important to collect samples for testing at the right time, in the right way, and in the right condition. The earliest that stalk nitrate samples can be taken is at 1/4 milk line. Milk line can be seen by breaking an ear apart and looking at the kernels towards the top or tip end of the ear. In this case, the milk line has migrated down about 1/3 of the way from the outside part of the ear to the center. After the milk line has migrated to the center and is no longer visible, the corn has reached physiological maturity. This is evidenced by the formation of the black layer. The black layer is visible by carefully scraping back the kernel tip. The test can be done up to approximately 3 weeks after black layer formation. You need to collect 10 representative samples from each field. Sample plants randomly from several parts of the field, taking care to avoid off-types and visibly diseased plants. Check the condition of the plants to avoid stalks with developing stalk rot diseases. An 8-inch stalk section beginning approximately 6 inches from the ground needs to be harvested for analysis. A pruning shears is a good tool to harvest samples with. You may find it convenient to mark the shears with a tape at 6 and 14 inches to make sampling easy and consistent. Here is an example of a good, healthy, disease-free sample. Experience has shown that cornstalk samples can be taken from fields that have already been harvested for silage, provided that there are a sufficient number of places in the field where the stubble has been left high enough to allow for the specified length of a sample to be cut, and if it is done right after harvest before deterioration of the stalk occurs. After the samples have been taken in the field, they need to be cut into 2-inch segments. Place these pieces in a paper bag or other breathable container so they will not mold. If the samples cannot be sent to a lab for a couple of days or over a weekend, keep them in the paper bag or breathable container and store them in a refrigerator. Do not freeze the samples, as this could alter the results. Based on the findings in the field research, Three ranges of test result values, low, optimum, and high, have been established. A test result of less than 700 parts per million is low and nitrogen likely limited yield. Nitrogen management should be evaluated to determine why the nitrogen supply was inadequate and management changed accordingly. There is a good probability that there would have been a profitable response to more nitrogen in this field. Corn probably was showing nitrogen deficiency symptoms. As the test approaches the optimum range, the likelihood of seeing a deficiency goes down. When the result is from 700 to 2,000 parts per million, nitrogen was adequate but not excessive for optimum economic yields in this field. Fields testing in this range are an indication of good nitrogen management. Ideally, you would consistently have your fields test in the optimal range. However, even under ideal nitrogen management, it may not be possible to be in the optimal range every year, but the long-term trend in test levels should be close to the optimal range. There may be some yellowing on the lower leaves before the corn reaches maturity. With over 2,000 part per million, nitrogen was in excess of what is needed for optimum economic yields. Not only might this represent an economic loss, but it may also indicate a potential for nitrogen loss to the environment. Try to determine the reason why the nitrogen supply was excessive and make changes accordingly. Corn grown on fields in this category will probably not show any yellowing in the lower leaves until the leaves start to naturally die off. The late season cornstalk nitrate test does have its limitations. If the nitrate level is low, the test cannot determine how much more nitrogen would have been needed to reach optimum yields. And if the test result is high, it cannot determine how much lower the rate of nitrogen should have been. The test should not be used for fields that have suffered from drought. Nitrate levels will be more concentrated in the plant and will read higher than they would have been under good growing conditions. The late season cornstalk nitrate test has been proven to be reliable. Done at the right time, under the right conditions, and in the right way, it serves as a good tool for improving nitrogen management in corn.